talking about, you're going to be talking about our experience with developing a solution related to basically ultraviolet sterilization systems for sterilizing and disinfecting surfaces in different areas and places using the UV technology, basically. So the way we went about this, we started it as a challenge, and the challenge for our team was how can they develop a working prototype within a one week time. So this was the main challenge that we were trying to address. I'll give you a little bit of a brief about the UV technology and the UV lights and how it can be implemented in basically disinfection and sterilization of surfaces. We call it contactless sterilization. So in this application or in this solution, you don't need to apply chemicals or any kind of solutions. Rather, you can do it with the UV lights. In general, I mean, we have a spectrum of UV light or the light in general. We are basically focusing on the ultraviolet, which is basically ranges from the wavelength of 100 to 400 nanometers. So yes, in that we can, the subcategories of the UV lights can be categorized into three categories basically. So we have the UVA, UVB, and the UVC. What we are interested in our solution was the UVC, which ranges between 100 to 280 nanometer. In this chart, you can see basically different applications of those categories of lights. So for example, the UVA are one of the applications of the UVA is the bug zappers. These are the devices that you can put in restaurants and homes, which basically kills bugs. Light therapy is basically can be used in these two ranges. For example, for kids, newborns who have jaundice, for example, or other medical conditions. You can use the UVB and UVA in areas such as printer ink curing, solid state lighting, medical imaging, protein analysis, and many other applications. I'll not go through all of these. The UVC is, as I mentioned, is what we are interested in and can be used in different applications. And this technology has been used for a very long time, basically. Such applications are used in water and air purification systems. It has been used even for in label tracking, barcodes, and even in UV detector optical sensors and instrumentations. Studies has shown that the UVC light in specific ranges is very effective against destroying viruses, pathogens, bacteria, and even fungi and molds kind of thing. And also studies have been shown that it is very effective against the coronavirus family. And recently there are a lot of studies being done on the COVID-19 itself. And so far we have very positive results that's actually very effective against the COVID-19 viruses, where it can actually destroy these viruses or basically make them ineffective kind of thing. The solution that we were thinking about and we started with and we decided to do the prototyping for was basically using a UVC light with a 254 nanometer range, which is basically, this is the range or the frequency that is proven most effective against pathogens and bacteria. And also using an autonomous, basically guided vehicle. Why it's called autonomous guided vehicle? Guided because actually it's going to be following a certain guide or certain kind of path. In our case, we used it to follow a line. So basically the idea was you can actually draw a line on the floor or install a line on the floor, and this robot will follow it in any space, in any pattern that we basically require. The next stage for our prototype would be to use the UVC 222 nanometer, this is a relatively new technology, which is called FAR UVC, and it has proven, I mean, the difference between this and the previous UVC light, which is 254 nanometer, the 254 nanometer has side effects on the skin and even in the eyes. So it's not recommended to use this with people around it kind of thing. So you have to use it either in places where there are no human beings around, or if you're going to be using it with human beings around, they have to be basically protected with protective gear and all these things. The UVC 222 nanometer has proven that it's effective against the pathogens and the viruses, but it is harmful. It's not harmful to the human beings. So the beauty about this technology is that basically you can use it in public spaces or people with high people traffic without having any side effects on the people and actually doing the job it's supposed to do to destroy viruses and pathogens kind of thing. So the next step for us is basically to use something like this, the UVC 222 nanometer with an autonomous mobile robot. So in that case, the robot has the capability of finding its way in any space, basically, as simple as that. So it will scan any space that it has, it will identify the obstacles and all these things, and it can basically find its way to go and do the virus disinfection process without a human intervention and without the need of having something like a guided line that can follow. So this is our next step for this project. Yes, so these are just like a small demonstration of how the robot actually works. So this is actually an actual setup in a factory setup where it is basically now trying to find its way around the space and doing the disinfection and sterilization process. So this was in a nutshell. I'll let my colleagues now talk about their experience and how they went about developing the prototype in 1 week time. That was a challenge, and this is what they did basically throughout this experience. So I'll just let my colleagues to continue the presentation.
All right, thank you, Ali. Hello, everyone. I'm Du'a Ali. I'm an electronics engineer, and I'm the FAB LAB Bahrain manager and program instructor to one of our programs. So before getting into like the actual producing of the robot, I just wanted to talk about one major factor of being able to do it within a week was the space that we used to do it. So here we are at FAB LAB Bahrain. If you can go to the next slide, please. I'll talk about what a FAB LAB is. So a FAB LAB is an initiative that actually started from a course, a course in MIT, we could say. So in 2001, a graduate level course was offered at MIT called How to Make Almost Anything. The whole point of it was to introduce non-technical students into technical tools and methodologies that they can use to create things. The response to that course was so overwhelming and so amazing. It showed that people are really interested in making things by themselves, are really interested in doing things on their own, by their own hands, even if they don't have a technical background. So that inspired, starting from the MIT Center of Bits and Atom, led by the professor that was teaching that course, Professor Neil Garshield, to start the initiative of Fab Labs. A Fab Lab is we could say, a place that contains several different digital fabrication machinery. Tools such as 3D printers, laser cutters, CNC machines, all in a single place. This initiative really did take off. At the moment, there's over 1,200 Fab Labs all around the world in all kinds of different countries. This map would really show you like how the number of Fab Labs that exist around the world. But the thing is, a Fab Lab is not really just about being a room that contains those tools. Like, it is more than that. If you go to the next slide, please. So there's 3 components that basically make up the concept of a Fab Lab. The tools is just one of those things. The most important part is the shared knowledge base. So those Fab Labs don't really operate independently. Not every Fab Lab would just do its own thing. There's a shared network and a shared knowledge that all those Fab Labs share together throughout this network that exists all over the world. And the second point would be a distributed educational program. So this educational program is actually based, or it's basically the same as the graduate level program that started the initiative of Fab Labs. So this program is also now being offered to a lot of people that are in a Fab Lab, so they can learn different skills, not just about digital fabrication, but also about what a Fab Lab is, I would say, and collaborative projects and local context. So there are multiple Fab Labs, again, around the world, but each of them can work on their own projects. They can work on it collaboratively, but every Fab Lab would normally focus on spinning off that project into something that would fit the local need. Obviously, with the COVID-19, it's kind of a global thing that is happening, but a lot of the time people would work together on projects that would fit their local needs, or they would alter like a project that exists somewhere else, work on it collaboratively, and then alter it in a way that would fit the local flavor or in a way that fits the local needs. So for the distributed educational program, it's called the FAB Academy. It's based on the MIT graduate level course. We've been offering this course for the past four years here in FAB LAB Bahrain with successful results, I would say. So during this course, the students would learn about different digital fabrications, but not only about digital fabrication, about how to work collaboratively, how to work to create a project, and how to prototype quickly to create something, and then alter that thing in case like the first prototype fails, for example, or the first prototype doesn't exactly fulfill the needs. So what FAB Academy does is that it encourages, not only teaches students how to use digital fabrication tools or machinery. That's something I would say that someone can learn anywhere or just learn online, but this really teaches students how to work together to create something, not only with the students that are present in the local lab, for example, in FAB LAB Bahrain, but also to collaborate with different students also taking the course all over the world. So I've been offering this for the past 4 years. We're offering this again this year. So this year we're pretty much nearing the end of the program with a group of students that are learning all that kind of different skills. Quick prototyping and, most importantly, altering the work as they go, using the skills that the tools and the machinery they have. One other thing about the Fab Labs, a part of being connected together globally, there are multiple events that actually take place annually. One event is called the FabX event that takes place globally, where people can come together physically in person and basically learn from each other's experience and learn what every other person does and share the knowledge. Other than that, there are smaller programs. For example, what you see on the screen in front of you, that is a small program that happened this year in January that I was a part of in Kerala in India, where a group of instructors from around the world came together basically to share the knowledge that they have from their own local labs and to learn together and create together. Basically share the knowledge and really emphasize that kind of collaboration that we can have when we have all those people in one place. So using all of those different tools, I would say that enabled our lab members to be able to create the UV robot within 1 week. Not only is it because they had the different tools in front of them, it's because we had people from all kinds of different backgrounds working together and collaborating together, using all the tools they have at their disposal in the lab, like different digital fabrication tools, and also going through the cycles of development really quickly, trying out something. If it doesn't work, discard it or improve on it and try something else. This kind of development cycle where you just keep doing things, you keep trying things in a critical manner, and you have a group of people of all kinds of different disciplines working together at the same time is, I would say, what the tool that we had that enabled us to create this robot within a week. So now I'll leave the floor to someone that was very involved with the robot's creation process, Abdullah, that will talk in depth about the different aspects of the robot itself.
Thank you, Dua. Can you hear me all? Just a test, small test.
Yeah, we can hear you.
Okay. So to start with, my name is Abdullah Fadi. I am a student in UOB. I'm actually proud that I am a student in UOB. I'm studying instrumentation engineer in the engineering department. And I was a part of FAB Academy cycle in 2019. Since then, I joined like all the programs that they offer till now. To start with, to make a robot, you will start with the mechanical structure. So yeah, next slide. Next. Okay, so this to make a structure, you will need some parts. So there are some available kits in the market that you can use to prototype the structure. To start with, we have the VIX. Some people know VIX from the robotic competitions. It can be used for competitions, as we can see, but also it can be helpful for prototyping the structure of our robot. Next. Next slide. Okay, there is another type of, let's say, VIX machine, VIX kit. Okay, the slides are lagging, but okay. To start, you have to assemble. You have a small, the beams. I'm not sure what. The beams. There is another industrial kit for prototyping structures. It's called aluminum beams. Okay, it can be used to prototype big structures in quick time. Next slide. Okay, this video show when we started building the structure. It was just a rough, simple structure with some motors. And actually, my friend Abdul Ghafoor, he was involved in VIX machine and VIX kit in school. So from this experience, he was able to help us prototype the structure very quickly. Yeah, so on the left, you can see the picture where we started, like generally taking the dimensions of the robot. So as you can see, it's just nothing, just some parts behind each other. And on the right, you can see after assembling some parts, we also found that the dimensions are not correct. So it's simple because you have a kit that can be assembled quickly. You can disassemble whatever you don't need and then reassemble whatever you see that is working. Next slide. So another thing let's say the robot has two parts, the bottom part and the top part. The bottom part I've showed you before, it holds the motors and the mechanisms and batteries and whatsoever. The other part is the top part. It has light holders, so we need to make a strong structure that can be assembled quickly and strong structure using the kit. So this is the rough structure before inside the robot. Next slide. I will talk about the other part of the process that we went is the digital fabrication tools. Next slide. As you know, our facility has different tools like CNC machines, laser machines, vinyl cutters, and whatsoever. I'll just talk briefly how those machines were useful to our project to make it quickly. And next slide. So my main goal, my main job was to create the outer shape of the robot. As you can see from the video, anything that you want to build, you have to start with the design. So I used Fusion 360 when we took some measurement from the robot, and this is the result of the design. I have a 3D model of it. Then I converted it to 2D models that can be cut using different machines. Next. Yeah, so I'll talk about some machines. The laser cutter, it can cut, next slide, it can cut different materials such as acrylic, cardboard, so it's useful for, it's also a quick machine. Next slide. It uses the laser beam to cut the file. If you have a 2D file as I have designed and taken the measurements, I can cut different materials. And by the way, we made a tutorial about a workshop actually on YouTube about the laser cutting, the laser cutter machine. Next. Now I'll talk about the CNC. It was very useful. All machines works with the same principle. You have an X-axis and you have an Y-axis, and you have a Z-axis with an actuator or whatever. So the main difference between all the machines are just simple thing. For example, the laser machine had a laser beam. The CNC machine have a router or like a rotating motor that can cut material. 3D printers, I'll talk about them after a while. They have extruder, so just change the head and you just have another machine. Next, please. So in general, CNC machines are used to create furniture, and not just furniture. It has a lot of uses, but the main use is you can create furniture using the CNC. Next. What you can start with, or the steps for rapid prototyping, you have to cut your first design. Like I took the measurements and then I used MDF, which is a medium density fibers, which is cheap, relatively cheap. And I cut my design using the CNC machine. Next slide. This will help me to reduce the cost. So before cutting the acrylic, as you can see in this video, it's actually a time-lapse video. So before cutting the acrylic, which is more expensive than the MDF, we can use the MDF to test our measurements. So this is what happened. I cut I cut the MDF material, which is cheap, and then I found out that there are some holes that have offset of position, like 1 or 2, 3 mm different. So using this feedback, I was able to get my design correct, and then I used the acrylic to cover the robot. Next slide. So this is the final result for the bottom part of the robot. As you can see, the blue parts all cut by the CNC. This is the second cutting. As I said, I used first the MDF and then the blue acrylic, as you can see here. Next. So for the top part, I used acrylic also. It was transparent acrylic, and then I engraved the FAB LAB logo on it. And then I painted the parts. It was transparent. Next slide, please. This is the final result. As you can see, the top part are match the fit with the top structure as I showed you before. And by the way, the black color in the whiteboard, it was cut using vinyl cutter, which is usually used for cutting stickers. So I cut some vinyl and then stick it here. Next. So this is again to remind you about the structure, the design, sorry. Now I'll talk about how we use the 3D printers. 3D printers, as I said, the machines have the same principle, X, Y, Z axis. For the 3D printers, they use extruder, which takes the plastic type, like PLA or ABS, and then it melts it. Then it prints each layer independently. Next. Yeah, so here I used the printer to print some parts. I didn't use the part. Eventually, I didn't use it, but the 3D printer gave me the ability to test the part. Is it even useful or not? So this part in the left, it was like an attachment for a button. We then found out that it doesn't work. We don't need even this part. So for the rapid prototyping, you have with this different tools, you can test quickly if this part will work or not. If not, you just keep it away. Next. Yeah, so before, can you go back one step? So to sum up, I have just three main goals for this my presentation. That if you fail fast, you will end up with a fast prototype. So as I give you the example of the CNC where I cut the MDF, it was quickly. The places equipped with different machines, I can prototype quickly. Different than if you have a design and then send it to China and then delay and whatever. So what I want to say that the place is equipped with different machines that you can use to rapidly prototype your project. And as a learning experience from this project, my experience in measuring or taking the measurement from the robot increased. So before I was a little bit scared or don't know this. So when trying things, you just learn more stuff. So in my personal opinion, I've benefit from this project. Next, and thank you for listening.
John, you can start your presentation.
Assalamu alaikum. This is Ghassan Youssef, Electronics and Communication Engineer and inventor of Take-On Platform. I'm a part of FAB LAB Bahrain. I am very happy to be working with them here. And here I would say it's the best place for makers, thinkers, and innovators. You have most of the machines that are ready to be used, and you have the experts who can help you bring your ideas to life. So regarding the robot, the UV light robot, we have planned and designed this robot in a way to behave in a specific way. So Therefore, we need to design the electronic circuits in blocks and then connect them together to work as a system. Okay, so is the slide okay? As you can see that electronic prototyping and embedded programming is very important to dictate the behavior of the robot. Okay, what we have done is used whatever available boards that we have, and we chose to use VEX because it's a ready platform, and it can drive the motors directly and the sensors. Learning new syntax of coding, of course, when you are dealing with something that is different, especially when you are talking about a new board. The programming syntax is differs from one language to another, but mostly they are the same, except if you are going to use Python, for example, or Java. Java has similar syntax, but you can fast adapt. Okay, next please. Okay, now in comparison, this is Arduino Genuino Uno, and we have the VEX on the left side. Now they are completely similar, but in the VEX they are using a higher end microcontroller which has many other peripherals like USB and stuff, but they function the same. They have the very same GPIO numbers, the same analog inputs, but also they have something additional, which is the motor controller driver, which is on board. That would shrink the size of the electronic circuit. So we went for the VEX for faster prototyping. Move to the next. Okay. Now, of course, there are different kinds of boards, which is ESP32, which is very famous as a node MCU to connect to the Wi-Fi for connectivity, and we also have the Raspberry Pi. But the main difference between the ESP32, the Arduino, and the VEX, that they are just microcontrollers. They control with the low-level language, doing basic stuff to control motors, to read from sensors. Whereas the Raspberry Pi is a larger brain. It takes a higher processing power. You can do image processing. You can do artificial intelligence with it, whereas the microcontrollers can't do that. So definitely you have a better processor, you have better RAM, and you have more accessibility and a GUI interface just like Windows, but they are using Linux, which is Raspbian. This, especially Raspberry Pi, we are going to use it in the next phase of the upgrade of the UV light robot, where we will add vision to the robot so it can go around the place autonomously. Next. Okay. This is how the syntax looks like in basic C, which is you have to include the standard IO, standard IO.h header file in order to print a message like printf hello world. But this is C language. Okay, so it's more similar to Arduino. It's also more similar to the VEX programming platform. So in other languages, the syntax might be a little bit different. Next, please. Okay. Now, this is on the left side, we have the Arduino IDE, which starts with a void setup and a void loop. Void setup is to tell the microcontroller what pins are doing what and exactly how they function. That's before the main loop starts. And then once it enters the loop, then you are in an infinite loop. So you have to build your flow of the program flow in the loop so that it goes around and stays looping in that loop. On the right side, which is VEX robotics. We don't have a void setup. We have one main loop, and the definitions are at the very top of the program. And it doesn't have an infinite loop, so you have to build your own infinite loop. So instead of here void loop on the left side, here you have to make while one, and then this whatever is within the while, it's going to loop within. So there are some basic differences, but as a technician and as an engineer, you have to have some kind of programming background. Next, please. Okay. Here is our UV light robot. We have two modes of operation. This is the first mode of operation, which is a line follower. The basic function of a line follower is that we will draw a line, and this line is going around the machines in the working area, so that it will take a specific path for sanitizing the place. And once it reaches to the end, it will stop by itself with a special algorithm made for it. When it sees an ending line, it just stops. This of course is in the current phase. In the upcoming phases of the upgrade, it's going to be fully autonomous, so you will have three modes of operation. The second mode of operation is using a joystick. Okay, next please. Using the joystick is a very handy tool because in most of the cases you want to override the robot. Let's say the robot goes in a wrong routine, or just skips the line, or malfunctions. There is a bug or something malfunctions. You need to have the ability to take over and control the robot by yourself as a human. And that's what we did. We did an algorithm while it's working in its line follower. It breaks the program if we press the emergency switch on the joystick. It will give me the full power of overriding the robot. And the robot also had, we embedded special features in the robot, which we added ultrasonic sensors, so that when somebody is moving or some obstacle is in front of the robot, it stops. It stops from a distance, just for safety. As soon as you remove the object or the obstacle, it will continue its function.